Jupiter has a lot going on, including enormous storms, strong winds, auroras, and extremely high temperatures and pressures. Recently, new images of the planet were taken by NASA's James Webb Space Telescope. Webb's view of Jupiter will provide researchers with considerably more information about Jupiter's interior. What has been discovered on Jupiter by the most powerful telescope in human history? Has it finally detected extraterrestrial life on this enormous planet? Should you be concerned about this finding? The shocking new discovery on Jupiter made by James Webb Space Telescope will change everything, so be sure to watch the entire video. The JWST's mission has a number of major goals, and its components are made to help it achieve these goals. The telescope is intended to look deeper into the cosmos than ever before, look for the earlier stars in the galaxies born after the Big Bang, better comprehend how planets, stars and galaxies are born and evolve, explore other worlds and study our solar system, and evaluate the possibility of life on planets surrounding other stars. This means the JWST can peer far into the universe. In fact, it will bring us the closest to the Big Bang as we have ever been. But this does not mean the JWST cannot see objects relatively closer to us. Scientists from NASA used the telescope to focus on the planet Jupiter throughout the testing phase, and the results were nothing short of amazing. Before we get into that, let's talk about the planet Jupiter first. There is a clear reason why Jupiter is named after the Roman deity king. Jupiter is the largest planet in the solar system, as all students have learned in school. This, however, is an understatement. Jupiter is by far the most massive cosmic body in the solar system, with a mass 2.5 times that of all the other planets combined. It is about 318 times more massive than Earth, and the diameter of Jupiter would require 11 Earths lined up next to each other. With its enormous size and mass, you'd expect Jupiter would move slowly around its axis. With a rotational velocity of 45,300 kilometers an hour, it is the fastest spinning planet in the solar system. As a result, a day on Jupiter only lasts 9 hours and 55 minutes. A year, on the other hand, is substantially longer. Jupiter orbits the Sun once every 11.8 Earth years. Furthermore, due to the planet's rapid spin, it has an oblate shape with flattened poles and a bulging equator. Its powerful rotation is also to blame for the next point. Jupiter's core, like Earth's, is composed of active swirling molten material, the motion of which generates a magnetic field, and a very powerful one at that. Jupiter's magnetic field is at least 14 times stronger than Earth's, making it the most powerful in the solar system, according to NASA measurements. Jupiter's rings, in contrast to Saturn's, are quite faint and consist of dust rather than ice. These rings were too weak for astronomers to see for centuries. Imagine how surprised everyone was when NASA's Voyager 1 spacecraft returned photographs of Jupiter's rings in 1979. The three-ring system begins 92,000 kilometers above Jupiter's cloud tops and extends more than 225,000 kilometers away from the planet. They range in thickness from 2,000 to 12,500 kilometers. Until recently, Jupiter was commonly recognized as the planet having the most natural satellites in the solar system. That is until 2019, when scientists at the Carnegie Institution for Science in Washington, D.C. increased the total number of moons around Saturn to 82, surpassing Jupiter's 79. Almost all of Jupiter's moons have diameters of less than 10 kilometers. This is why scientists are continuously discovering new moons around Jupiter and Saturn. Some of Jupiter's moons stand out more than others. These 4 main moons are known as the Galilean moons. Io, Europa, Ganymede and Callisto are their names. Ganymede is the biggest moon in the solar system, with a diameter of 5,262 kilometers. And who knows, Jupiter may reclaim its status as the planet with the most moons, with JWST now functional, as astronomers believe it has up to 200 natural satellites around it. Some of these moons may even be capable of supporting life. The Voyager and Galileo missions, which delivered spacecraft to Jupiter and its moons, discovered that Europa has a deep liquid ocean coated in thick ice. Scientists now believe that Europa could support life because it possesses 3 crucial conditions: biochemically useful chemicals, a source of energy, and a liquid solvent in which dissolved substances can chemically react with one another. But in order to find life on Europa, we must first penetrate the ice by sending a lander to the surface, possibly with a submarine. In July, NASA released first images of the telescope's commissioning period on the Space Telescope Science Institute's Mikulski Archive for Space Telescopes. The data includes images of Jupiter and images and spectral of several asteroids, captured to test the telescope's instruments before science operations officially began July 12. The data demonstrates Webb's ability to track solar system targets and produce images and spectra with unprecedented detail. Jupiter fans may recognize some familiar features of our solar system's massive planet in these photographs captured by Webb's infrared camera. A view of the planet from the NIR-CAM instrument's short wavelength filter shows distinct bands encircling the planet as well as the Great Red Spot, a storm large enough to consume the Earth. When combined with the deep field images released the other day, these Jupiter images demonstrate the full range of what Webb can observe, from the faintest, most distant observable galaxies to planets in our own cosmic backyard that you can see with the naked eye from your actual backyard, said Brian Hollier, a scientist at the Space Telescope Science Institute in Baltimore, who assisted in the planning of these observations. Europa, a moon with a possible ocean beneath its thick icy crust and the goal of NASA's upcoming Europa Clipper mission, is clearly seen at left. Europa's shadow can also be visible to the left of the Great Red Spot. The moons Thebe and Metis are also visible in these images. I couldn't believe that we saw everything so clearly and how bright they were, said Stephanie Millam, Webb's deputy project scientist for planetary science based at NASA's Goddard Space Flight Center in Greenbelt, Maryland. It's really exciting to think of the capability and opportunity that we have for observing these kinds of objects in our solar system. Scientists were particularly excited to view these images because they demonstrate Webb's ability to see satellites and rings around bright solar system planets like Jupiter, Saturn, and Mars. Webb will be used by scientists to investigate the exciting subject of whether we may observe plumes of materials shooting out of moons such as Europa and Saturn's moon Enceladus. I think that's one of the coolest things we'll be able to do in the solar system with this telescope, Millam added. Webb also readily captured parts of Jupiter's rings, which are especially visible in the NIR-CAM long wavelength filter image. The rings appearing in one of Webb's initial solar system images is absolutely stunning and amazing. The Jupiter images in the narrowband filters were designed to provide nice images of the entire disk of the planet, but the wealth of additional information about very faint objects, Metis, Thebe, the main ring, hazes, said John Stansbury, observatory scientist and NIR-CAM commissioning lead at the Space Telescope Science Institute. In 3 different exposures, Webb captured images of Jupiter and Europa travelling across the telescope's field of vision. This test confirmed the observatory's ability to locate and follow guide stars in the neighbourhood of brilliant Jupiter. But how quickly can an object travel while still being tracked by Webb? This was a critical question for asteroid and comet researchers. During commissioning, Webb began the moving target tracking speed limit tests on an asteroid called 6481 Tenzing, which is located in the asteroid belt between Mars and Jupiter. With a top speed of 30 milliarcseconds per second, Mars was the benchmark against which Webb was built to track objects. The Webb crew observed a variety of asteroids during commissioning, all of which were small enough to be seen as dots. The team demonstrated that even for objects moving at speeds of up to 67 milliarcseconds per second, which is more than double the baseline and is comparable to shooting a turtle creeping from a mile distant, Webb will still obtain useful data. Everything performed flawlessly, according to Millam. On August 22nd, NASA publicly released new telescope images of Jupiter that display auroras, cloud cover, and altitude. The most recent images depict bands of blue and grey in the planet's centre, with rainbow-coloured colours in its poles. Imke DePata, a professor of planetary astronomy at the University of California, Berkeley, remarked, "We hadn't really expected it to be this good, to be honest. The fact that we can see intricacies of Jupiter, its rings, tiny satellites, and even galaxies in one shot is very amazing." The picture's red hues depict auroras, while their yellow and green hues depict hazes circling the poles. The white bands and spots show cloud cover, including the Great Red Spot, a massive storm that could swallow Earth. The brightness here indicates high altitude, so the Great Red Spot has high altitude hazes, as does the equatorial region. said Heidi Hamel, Vice President for Science at the Association of Universities for Research in Astronomy. The numerous bright white spots and streaks are likely very high altitude cloud tops of condensed convective storms. Likewise, the darker areas are ones with little cloud cover. Photos with a wider view show the planet's rings and two moons, Amalthea and Adrastea. Webb will deliver observations about every phase of cosmic history, but if scientists had to pick one thing to be excited about, it would be more Webb views of star-forming regions. In particular, they are fascinated by young stars that produce powerful jets in small nebula patches called Herbig-Haro objects. We're really looking forward to seeing these weird and wonderful baby stars blowing holes into nebulas. What do you think? Will we see more of these baby stars in the future? And what secrets do they carry? And will scientists unearth more Jupiter mysteries? Let us know in the comments section below.